Now, with arrangements, we need to consider when we have duplicates. And so this is most common when we're working with letters and words. So what we have here is how to remove the duplicates. So if we have a number of arrangements of AAA, BBB, CCCC, how we work out the number of arrangements is this. As a numerator, we have the total number factorial. So it doesn't matter if there's repeats, just count them all up. So it'd be 10 factorial in this case. And then we divided by essentially the number of repeats. So here we see that A is repeated 3 times. So we divided by 3 factorial. And that's because we're removing the number of arrangements that are exactly the same. So within that A, there was 3 times 2 times 1 ways it was arranged, but they would still be exactly the same because they're all A's. So that's why we divided by 3 factorial. And same for B, there was going to be 3 factorial ways that they're arranged but still look exactly the same. And now for C, there'll be 4 factorial ways that those C's would arrange within themselves, but you would have still gotten exactly the same arrangement because it's C. So that's why you get 10 factorial divided by 3 factorial, 3 factorial, 4 factorial. So remember, in this case, what you do, count them all up. So that's your numerator, and then you divide it by the repeats. So if there's 3 repeats of A, you divide by 3 factorial times repeats of B times your other repeats. Okay? Now, another example to consider is if we had A, B, B, C, 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 D. So in this case, 1, 2, 3, 4, 5, 6, 7, there's 7 letters altogether. So it's 7 factorial. Now you can also consider this method as, well, there's 1 A, so that'll be divided by 1 factorial, 2 B's, so 2 factorial, 3 C's, 3 factorial, and 1 D. So that's another 1 factorial. But there's actually no point writing your 1 factorial and 1 factorial because it's just 1. So that's why we only divided by your 2 factorials, 3 factorials, so on. So it's actually writing them all out like this, but there's no point writing the 1 factorial. And you actually see that if you do write it out like this, 1 plus 2 plus 3 plus 1, you should add together to 7, which is the number that you have up here. Okay? So it's just good to understand where you get this concept from. Okay, so this is your general rule for removing duplicates. Let's have a look at it in practice in our questions. So let's start off with question 24. And we want to find out how many different 6-letter words can be formed from the letters of create. Now, words is shown like this because it doesn't have to be a specific word, yeah? It's just asking for arrangements. In this case, you want to consider firstly, the numerator, so how many letters there are, and that's going to be 6 letters. So there's 6 factorial ways they can be arranged, but there's 2 E's, right? So those 2 E's are identical. So they can be switched around and they would be exactly the same, which means you're going to have 6 factorial divided by 2 factorial. The total number divided by your repeats. And that gives you 360 ways. All right, this is actually some of the easiest questions in permutations and combinations. So I hope you see this in exam, you'll definitely get it right. Just remember total number of letters, then divided by the repeats. What about here? In question 25, we want to find out how many ways may the letters in weightlifter be arranged. So we want to consider all the letters. And when we consider them, we see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But there's going to be E is repeated twice, I is repeated twice, and T is repeated twice. Now, in the previous question, it was really easy to see that E is repeated. But in these questions, a lot of people just make silly mistakes because you actually just don't count properly how many repeats there are. So I find the best way to do this is just write it down the page. So you just write weightlifter like this. And whenever you get to a letter that's repeated, just write it next to it. And if you go along like that, and that's going to be E is repeated and R was repeated, then you'll see that you get all the letters that's repeated together. Does that make sense? So you don't miss out any of them. So I find that's the easiest way. Just write it down the page and go along, and then you definitely won't miss any of them. All right, so let's consider this. We said there was 12 letters altogether, and E, I, and T are all repeated. So we have 12 factorial divided by 2 factorial for your E, times 2 factorial for your I, and another 2 factorial for your T. So that's actually going to be 59,875,200 ways. So a lot of ways that these letters can be arranged. All right. So with these questions, honestly, the most common mistake I see is just from students who don't count how many repeats there are properly. Especially when it's a long word and you have 3 repeats of I, it's easy to miss out on one. Just do that technique and you'll be fine. Let's look at a slight variation. So here we have how many ways can the letters in Grand Slams be arranged, but the letters in Grand have to stay together and the letters in Slams have to stay together, okay? So firstly, we consider them separately. So firstly in Grand, there's no repeats, so it'll just be 5 factorial. Now in Slams, the S is repeated, so that's why we'd have 5 factorial divided by 2 factorial. They have to stay together, but it doesn't say which order they have to be in. So it doesn't say Grand's letters have to come first. So you have to consider if Grand comes first or Slams come first. So in that way, they can actually be switched around 2 ways. And that's why you have that multiplied by that times 2 ways that it could be. And just put that in a calculator and you should find there's going to be 14,400 ways that Grand Slams can be arranged.